Thank you. All right. So happy to be here today. I hope you're all still awake at the end of a long day. I wanted to take 35 minutes to talk about Neo4j and NeoDash. And not just NeoDash, I wanted to take it a bit bigger, the entire topic of visualizing graphs and how it fits within a Neo4j project. So let me dive right in. Right, my name is Niels. I'm working as a consultant at Neo4j, and what that really means is that I do full stack Neo4j development at Neo4j's customers in Europe. So this could be anything from data modeling to API development, visualization, GDS, but visualization is really my favorite topic of all time. That's why I'm here. Right, so my message here today really is that visualization fits within many parts of a Neo4j journey, really starting from the modeling itself to writing queries, to exploration, and eventually dashboarding and making reports for end users. So I'm going to hope that I can fit this in 30 minutes, but the ultimate goal today is to build an interactive rail planner powered by Neo4j. So just to set the stage before I dive into the live demo part, what is graph visualization? So this is my personal definition of visualization. So for me, graph visualization is a method to understand and explore and make decisions on graph data. So this is a pretty broad definition, but it really spans many different aspects. So in my world, visualization is really part of almost every Neo4j project, because in the end, the human beings are going to be the ones working with the graph, and those will want to see a nice visualization. So important here is that graph visualizations are not just the force-directed layouts we all love, but it could even be a flow diagram like this Sankey chart, for example. Very different way to look at your graph, but still a graph visualization. And if you have geographic data, so data with coordinates on them, your graph could even be visualized on a map. So to me, that's also a graph visualization. So really multiple different types that together make up this category of visualization tools. But it's not just the type of visualization. It's really also the type of tool that you're using. That's very important. So as I said, a project has many different goals, and different goals require different tools. So to walk you through 4 tools today, I'm going to start with modeling. And a modeling tool that we like to use is arrows.app. So a modeling tool is really just a virtual whiteboard for drawing a graph schema. So you can draw nodes, you can draw edges, you can draw properties on the nodes and relationships. And it's a communication tool. So there's typically no animations, but styling options, adding nodes is very important there. A type of graph visualization, really just like the ones that we're used to seeing. Then moving on, once you have your model in place, you probably want to load your data and you want to run some queries. And the output of these queries will also be graphs, right? So you need a different tool to visualize the result of your ad hoc queries. And that's where analytics comes in. So the Neo4j browser is a great example of this. You can write Cypher quickly. You have small views, but you can iterate quick, and you can add some simple styling and run some algorithms. So that's the next visualization tool that comes into play. Then the next step, you got your data loaded, you've got some queries for developers, and you want your analysts to be able to see the data, right? Explore the model. And maybe these people don't know Cypher. So this is where a tool like Bloom can come in and really have a no-code interactive way to see your graph and explore it and walk through it. So again, a different type of tool. These tools like Bloom, they can do bigger graphs. They have nice styling options, custom exploration. Very different purpose from the previous two, but all of them together, they fit into this journey, right? Then the last one, and this is obviously my favorite, is dashboarding tools. So you've got your developers that write queries, your analysts that do exploration, but you also have your business users. And these are the people that they don't necessarily know Neo4j or Cypher or even the data model, right? They just want to make decisions on data. And that's when you give them a very curated dashboard with maybe tables, but also graphs or maps or bar charts. And the key word here is actionable insights. So these are people that want to make decisions on data. And that's where a dashboard comes into play. And NeoDash is a tool to accomplish this. So diving deep into NeoDash. So what is NeoDash? It's a low-code dashboard builder for Neo4j, open source. And this is a project that I started about 2 years ago. And I have currently a lot of people helping. There's support from the community, people inside Neo4j. So it's become a really nice, big project, much larger than what I expected 2 years ago. And it's been seeing quite some interest in the community. People love to use it to prototype dashboards or even bring their dashboards to production. And I'll show you a demo of this in a bit, of course. And this is a tool that sits within Neo4j Labs. So it's not a Neo4j product. It's a community supported kind of incubator tool, just like Neosemantics and some others. So great to use this together with your other tools. So we're talking about rail planning today, right? That's the topic. So I wanted to zoom in on some of the features that NeoDash has for visualizing geographs, so graphs with position data. So we can imagine the traditional view where you have nodes and relationships on a map, where NeoDash is able to map a points property from Neo4j automatically onto a position on a map and visualize that. But it could go even further. You could have country data. You want to see numeric values, for example, on a map per country, so population. And this is called a choropleth map. And this is also something that we have in NeoDash at the moment. Then the third option right now is a heat map. So visualizing data, let's say the frequency of points in a specific location. And heat map is a great way to see that. So a lot of these things were inspired by some of Estelle's work on NeoMap. If you haven't seen it, check it out. Very, very cool tool and very interesting to integrate that into NeoDash. And this has been also an effort by the team working on NeoDash. So really, really cool work here. So, but yeah, so let's dig in, right? We have all these tools available, and I just want to show you how they come together to fix a real problem. So in this case, building a rail planner for the European rail network. All right, so I wanted to show you first the data set that I picked. So I was looking for an example of a project where visualization comes in many places. So I found this really cool data set published by Open Data Soft, which is actually it's two tables, one with all the stations in Europe, so the stations with their coordinates, and the other one with the tracks, so the track fragments that are making up this giant network. So we have about 8,000 stations in here and 88,000 tracks, each of which consist of segments. So maybe it's best if I just show you the data. So this is the source data, one of them, the network of track segments. And as you can see, every track has a location, but it also has a shape. And when I hover on this, it even shows a little map preview here. So you can see that one track consists of many segments. And these make up kind of a curved line, and the curved line is this track, and the segment is kind of a straight line. And you can see here that we have coordinates for them, which is cool because we can put those in Neo4j. And we have some other information like which country it's in, a couple of codes that mean how it's used. Is it a military track or is it used by commercial trains? Some of them have names as well. So we can all put this into Neo4j together with the stations to build up this rail network. Right. So the properties, I just talked to you about them. We have for a station, we have the ID, the name, the coordinates, when it opened, country code, and the usage category. So is it a commercial station or not? Then the tracks, we have ID, name, coordinates, and then this list of segments, right? But also we have the maximum speed that a train is allowed to go. And that's actually really useful because it lets us make an estimate of how long a track would take to ride over, right? So we have the distance of the track and we have the speed, so we can calculate how long is it going to take to go over this track, and that's super important for the routing use case that we're doing. All right, And again, this is quite nice with Neo4j. We have spatial functions, which allow us to calculate the length of a track. And then with the max speed property that I just mentioned, we can estimate how long will it take to cross over this track. And then the problem here was, can we come up with a real planner by just looking at the infrastructure? So ignoring train times, ignoring train schedules for now, just looking at the infrastructure itself. And that's where we get into our little journey here. And why I wanted to show you how each of the phases in this project is involved with a different tool, a different visualization tool. So we're going to start off with data modeling. And I just wanted to show a little bit of background here on the concepts that I used for building this network. So we have stations. Stations are places where you can get on and get off, obviously. And we have junctions, and junctions are points where two tracks meet. So when a train is going over a track, at some point the track splits, right? It can choose to go in one direction or the other, and that's a junction. And we use this as an entity in the routing network. And then points are the segments, let's say where a segment starts or ends. So in this example kind of sketch on the right, we see that the red dots are points, the yellow dots are stations or junctions, and the lines are segments. And as I said, we have relationships in the graph. A track can consist of several segments, which can be curved, and a single segment is a straight line. And then what we eventually want to do is create route relationships, where a route consists of multiple tracks and ends and starts at a junction or a station. So this will be kind of the ingredients for our planner that we're building, essentially, right? So first thing that I want to show you is the data model. And I'm going to jump over to Arrows, which is a free tool that you can use for modeling Neo4j. And this is technically not a data model, it's more an instance, right? So we can see, I try to draw an instance of what a piece of the network would look like. So I'll just explain this to you quickly. We have station nodes in green, and stations, they have, for example, a track leaving from it to a point, and that point might have another track going to another station. And these two tracks, they make up a route between station 1 and station 2. Now we also have track segments. So this track consists of two small segments that are kind of the curved track. And this is in higher level of abstraction, the distance between a station and a point. And then, as I said, the junction is where multiple tracks come together and the train can decide to go in direction 1 or direction 2. So this is a really nice tool. And one of the things that I haven't done yet, which I just want to show you quickly, is adding properties. So as I said, on each track and every route and every segment, we have a length, which is, let's say in this case, well, let me pick a better example here, maybe this one here. We have a length of 300 meters. And because we know the maximum speed, we can calculate that this will take travel time, seconds, maybe that will take, let's say 30 seconds. And this is actually what the graph will look like in the end. These properties are stored on the route relationships and on the tracks. So arrows.up is a nice way to get modeling and draw instances and explain the idea to your audience. Right, so we have our model in place, and now we can start loading up the data. So I have created a GitHub repository, which I will share. And this has a bunch of queries in it that load the data. You can run it locally and create this graph for yourself. So I won't show you the entire script right away, because I think it's going to take too much time. But what it essentially does is it clears up your database, creates constraints for you, and loads up two CSV files, so the railroad segments and the stations into the graph. And this script as well takes care of calculating these distances that I talked about, the travel times, and creating these route relationships. It takes about approximately 2.5 minutes to create a network that is fully routable. And I will show you in the Neo4j browser how we can use that. So moving on, we have loaded the data. Now we can try running some Cypher queries, right? So I'm going to pick one of these queries. and actually go back into full screen and jump to my browser. So I cheated a bit here because I already loaded the data earlier, which means that I can now run some queries. So this query here, and I think I will zoom in a little bit so you can read it. This query here is going to find the shortest path between two stations. So we have a station N and a station M. N is Rotterdam Central Station, and M is Den Bosch, which is a very hard word to pronounce for non-Dutch speakers. But by using our network now, we can use the Dijkstra's algorithm to find the shortest path between the stations. So if I run this, the browser will give me a graph visualization showing me the route between the different stations. So here we start at Rotterdam Central right here. Then we hop over these kind of red nodes, which are the junctions. We cross a couple of other stations and eventually end up in Den Bosch. So this is as you can see, we now have this whole thing available to run such a nice routing. And the fun part here is we can run this both with distances and travel time. So if I tell my algorithm here to use the travel time in seconds to find the best route, I can run this again, and we actually see that it finds a different algorithm. So I mean, it finds a different route, right? First we went by 1, 2, 3 stations, and now we only crossed 2 stations. So by estimating travel time, by estimating a route based on travel time, we actually get a different result than using the distance-based measure. So that is a very cool way to see how this makes a difference, and also how the Neo4j browser can be used for visualizing this kind of analytical queries very quickly and prototyping essentially the different things here. So heading back to the slides, and I'm being cautious of time. Moving on, we have our data loaded, we checked that we can do some routing, and now we can try out some Bloom, right? So I'm going to jump into my Bloom instance here. And I just wanted to show you what Bloom looks like. So Bloom is completely no code. You can navigate your graph without writing any cipher. So if I started a station, for example, again, Rotterdam Central Station, you'll see that I'm typing here just natural language, right? And Bloom figured out that I'm talking about this node with this label, which by itself is already pretty nice. And then I can see, okay, how far can I go from Rotterdam? So let's see, if I do, let's see, 1, 2, 3, 4, 5 hops of route relationships, where does that take me? So I can run this, and then Bloom will show me a very nice graph here and says, okay, I started Rotterdam Central. I can cross these junctions and end up in Schiedam or in Delft. And then with Bloom, I can also expand from here and explore, go from Delft to Rijswijk, and I can go from Rijswijk to another junction, and maybe that will take me to some more places. And you can freeform walk through your network with Bloom, which is great because you don't have to know any cipher and you can do some nice exploration here. Now, that's Bloom. And to wrap up this conversation, I just wanted to show you NeoDash. So as I said, NeoDash is a tool for building dashboards. So I'm going to get my, let's see, I'm going to get my query that I had here that did the pathfinding using Dijkstra's algorithm, and I'm going to put that into NeoDash. So I have NeoDash open here, connected to the database, and I'm going to add a report, which is just a box that has a cipher query in it. So I'm going to take my cipher query from just now and show this as a graph visualization. And then I see pretty much the same thing that I saw inside my browser, Rotterdam Central, ending up in Den Bosch. Now, the cool thing about NeoDash is I can take this exact same query and turn this into a map. And because these nodes have geospatial attributes, NeoDash is aware of that and can plot the result on a map. So I'm just going to make this larger so you can see that. And now we see, as we expected, a route that starts in Rotterdam and ends in Den Bosch. So that is pretty neat. But where it gets super interesting is when we make this interactive. So what I can do is I can add another visualization to NeoDash. And for example, I want to see all the stations in the Netherlands. So I can do s.country code 3 is NLD, which is a 3-letter country code for the Netherlands. And then I can return the station name. And maybe I want to see the station type as well. And we can plot that in a table. So now we have a nice table here with different stations in the Netherlands. And where it gets fun is if I turn on my extensions here. So this is a new thing in NeoDash is something we call extensions. And one of them is called report actions. And these add interactivity into your dashboard. So go toggle this on. And now if I open this query again, I see an extra button that says set report actions. What I can then do is add a trigger. If the user clicks on the station, set parameter NeoDash station name 1 to station. And if I save that, it turns my table into a table with buttons. Now, you'll see where I'm going with this. If I make another table, so I'm making the exact same table here. And I'm also adding an action on this one. Same thing, if I'm clicking station name, if I'm clicking on the station, I'm going to set station name 2 to station. So now I have two tables that I can click this button on, and now I'm going to parameterize my original query. So here I can plug in NeoDash station name 1, and I can plug in NeoDash station name 2. And what I can do now is choose a station here, and this visualization will automatically be updated to show the route between the stations that I chose. So interactive, an interactive railway planner. It's already kind of here. Now, I just wanted to show you, this is obviously something that I can do in 1 minute, but if I take a bit more time to make a nice dashboard, what that could look like. So I have a prepared dashboard here that I can load. So I click on the load button. I load up my JSON that I created. And now I can see this dashboard that I created earlier, which is the real planner for all stations in Europe. And what I can now do is go from Rotterdam to Berlin, Friedrichstraße. And you see that this updates automatically. Now we have our entire route from Rotterdam to Berlin. It takes approximately 6 hours, this long. This is my average speed, and I'm visiting 19 stations. And the speed here is really what's amazing about Neo4j. We can do routing so quickly with the access algorithm. So we can even go, for example, from Glasgow and see that we're crossing, let's say in this case, 3 different countries. We're also crossing the Eurotunnel here, which is very nice. And 14 hours takes it to one station to the next, crossing over 3,374 segments. And I promise you another view here. So I just wanted to show you the other maps that we can see with NeoDash. So we have a chloroclast map where we have the numeric values for each country. We can see the number of stations per country. When you hover over it with some color coding, we can do grouping. So if I zoom in here, you see that it kind of aggregates the stations into groups. And if I click in it, it will zoom in and show me the individual stations on the map. And then the heat map, I can see the density of stations, right? We see that in Holland, there's a lot happening here. The center of France, not so much. So we can see the density of stations all over Europe. So that is NeoDash. And really what we've seen now is kind of a full journey here from modeling to loading the data, to querying, to exploring, and then dashboarding. And the message that I want you to take home is really that visualization is part of every part of your project, right? So every step of the way, visualization helps you do this more efficiently and helps you communicate to your users. It's really a Swiss Army knife. And the thing is that it's never one tool that does the job. You'll always need multiple to do the trick. And these are some of the tools that you can use. All the data that I made here is available for free. So I made a GitHub repository. You can find the source data and this dashboard as well. You can see the dashboard that I just created in the NeoDash gallery. So the NeoDash gallery is a website where we collect NeoDash dashboard that are made on public data. So if you go to NeoDash-gallery.graphapp.io, you can see a couple of dashboards, and if you click on load here, you can try out the dashboard without loading anything into Neo4j. It's a public database. That is it for my presentation. I haven't had time to look at the questions. I hope this was interesting. And yeah, looking forward to answer some questions.
It definitely was. It was too fast. That's a negative point. It was
too fast.
Too short. Sorry, too short. So yeah,
I try to fit it into 30 minutes.
Yeah, before we come to some questions, here is the wonderful feedback you got. Yeah. Whoa, so many. I hope you can see this phenomenal example. That's exactly what I needed. Neo4j is an amazing tool. Yeah, there were some questions that got raised. In the meantime, whoa. Yeah, wonderful feedback all the time, all over the feed. I need to scroll now because all the people are clapping. Yeah, so maybe you can answer this. I cannot answer this. But maybe it's even just more interest than Neo4j will specific. Is there a tool to represent geographic data in 3D, considering elevation?
A tool to represent geodata in 3D. With direct Neo4j integration, not that I'm aware of, no. They're probably out there, but not directly integrated with Neo4j, as far as I know, unfortunately.
All right. So maybe another person in the chat has an idea, has anything seen before. So you can pass this on to Philippe. So yeah, there's also a question about sensitive data. So Danubio asks, when dealing with sensitive data, what are the concerns of using NeoDash? I think he refers to that it's hosted somewhere or needs to get hosted somewhere.
Yeah. So the NeoDash that I showed you was inside Neo4j Desktop. There's also a public environment on neodash.graphapp.io, but it's an open source application, which means you can clone the app yourself and host it within your own, let's say, secure system, right? So you can use your own deployment of NeoDash to be safe and make sure that your data stays within your private network. It's possible.
Great. I just need to look over because you've got phenomenal feedback on this. Let me scroll a little bit. I don't think there are any questions. It's all the way positive feedback on your talk. So yeah.
Great. And I see
So it's open source. You also take pull requests, right?
Yeah, absolutely.
If
so
anybody's interested to support you, for example, with an integration of 3D map representation.
Yeah, absolutely. I mean, there you can make, if you have requests, you can make an issue, or you can of course contribute. There was a presentation earlier this morning of some people that forked NeoDash to make a solution for cybersecurity, which is really nice, and they are also contributing back. So it's really an open source ecosystem here that everyone can contribute to.
Yeah, and yeah, the question. There's no question. Yay. Ahmed asked, you've demoed interactivity at the table level. How far can we go with interactivity on the graph itself? So
yeah, that's a good question. So in terms of interactivity, with these report actions that I showed, you can define click events for nodes as well. So let's say you can add a trigger that if a user clicks on a node, another visualization gets updated, similar to how you would click on a table cell. So in theory, you can set up a click event in one graph to set a parameter, which then updates another graph, and you can create a chain of graphs that are all interactively related with each other. So you can get creative and make a really nice journey here in NeoDash.
So I think you're looking forward to all the examples you get after today, what people create, come up with. That would be good to give feedback to Niels. Yeah. And yeah, I think that's it. Glad you were here.